Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 28, Types of Chemical Reactions, Part 3. Here are our objectives for today's video. Pause here. So you're probably pretty familiar with the concept of diluting because you've probably mixed things with water before or added water to something to make it less concentrated before. Same thing applies in chemistry. You're lowering the concentration of something by adding pure water. I put pure in quotes just because no water is pure water, but for our purposes, we can think of it as being more or less pure. So we could actually just do a whole complex calculation where we calculate number of moles and divide by new volume, but that takes a really long time. So we can just use this formula right here, M1V1 equals M2V2, to determine the new concentration. M1V1 being initial concentration times initial volume is equal to final concentration times final volume. This works out because it actually means just moles is equal to moles, meaning we're following the law of conservation of mass. Pause here. Right, so I'm going to work through this pretty straightforward question. So I'm looking for M2 here. Because both of my volumes are in milliliters, I actually don't need to convert them to liters. It wouldn't be wrong if I did though, so if you prefer to, go ahead and do that. Everything in here has 3 sig figs, so I'm going to round to 3 sig figs. So I got 1.61 molar. And then this isn't like something that works 100% of the time, but after you do a question like this, just sit and think to yourself, does this make sense? And in this case, yeah, it makes sense. I'm going from 16 molar and 25 milliliter. I'm taking that volume, I'm multiplying it nearly by 10, and lo and behold, the molarity is decreased by a volume of approximately 10. So just think, does it make sense? Because it's really easy to just accidentally make something V2 instead of V1 just by mistake. And if you just think to yourself, does this make sense? You'll prevent yourself from making those sort of mistakes. Pause here. Right, again, very, very similar sort of question. Everything has 3 sig figs here, so I'm going to have my final answer be 3 sig figs. And then because my volume was in milliliters for my V2, my V1 is also going to be in milliliters, so I got 167 milliliters. Again, I think to myself, does this make sense? Yes, it's less than 500 milliliters. I'm going from 18 molar to 6 molar, so all the numbers make sense here. Pause here. So now that brings me to how we actually do this in a lab. So typically you're going to do this in something called a volumetric flask. I will, if I haven't already shown you one of these, I will when we go over this video during class. These are just devices that, like flasks that are designed to a specific volume. So a 250 milliliter volumetric flask is only good if you're trying to make 250 milliliters of a solution. What's really, really important, especially with strong acids, is you're going to add some water to the volumetric flask before you add any sort of solids or any sort of concentrated solutions. So if I were to use the example, in example 6, I would need a 500 milliliter volumetric flask. I know I'm going to add 167 milliliters of my acid to it. Before I do that, I'm going to fill my 500 milliliter flask up at least halfway with water before I add my acid, and then I can use like a dropper to get it all the way to volume. The reason why it's so important is because dissolving it or diluting in water is often a very, very exothermic process. So you need some water there to absorb the heat. Otherwise, you could have a very, very violent reaction. Great, that's all for tonight. Thank you so much for watching and have a great night.